Various climate models continue to be developed that offer regional projections of future climate under various emission scenarios. The models include natural factors, solar, orbital, ocean cycles, as well as human factors, aerosols, ozone, land use, and greenhouse gases. A recent synthesis of many studies estimated that the fraction of species at risk of extinction due to climate change is 5% at 2 degrees warming, and this increases to 16% if warming reaches 4.3 degrees warming. A video by CSIRO describes the different types of biodiversity that make up the web of life. It explains the wide-ranging benefits of biodiversity, which includes the economic values, ecological services, cultural values, recreational values, and scientific values. The combination of long-term climate and extreme weather events is starting to have impacts on biodiversity around the world. This is being called the press pulse effect. As the climate changes, there are three main ways that animals and plants can cope with change. One is to adapt, two, to move, and three, go extinct. One example of a species being impacted by temperature are the northern green sea turtles that only have females when the sand temperature is above a threshold of 29.1 degrees. Another example is the pencil pine trees that are endemic to Tasmania's high country, found 800 metres above sea level. The slow-growing pencil pines are vulnerable to climate stresses such as wildfires from increased dry lightning with climate change. The negative impacts of climate change and biodiversity are projected to increase with every 0.5 degree of warming, so limiting global warming well below 2 degrees Celsius is the most important solution. Some of the impacts that are expected with high confidence and certainty from the IPCC and IBES 2019 reports. Impacts are expected to be geographically variable in terrestrial marine systems. Populations that are able to move are expected to continue moving towards the poles and up in elevation. Local species extinctions are expected particularly in the tropics and in polar regions, deserts and alpine areas. Ongoing climate change is projected to greatly increase the number of species under threat of extinction. More species are experiencing range contractions and less suitable climate conditions than are expanding their ranges. Climate change is projected to decrease net primary production in the oceans by 3 to 10% and fish biomass between 3 and 25% by the end of the century. This is on top of impacts by habitat loss, overfishing, and pollution. Novel communities are expected to emerge where species will occur in historically unknown combinations. Substantial climate change-driven shifts in terrestrial biome boundaries are expected in coming decades. This is particularly the case in the boreal, subpolar, and polar regions, and in semi-arid and arid environments. In contrast, rising atmospheric carbon dioxide can be beneficial for net primary productivity and enhance woody vegetation cover, especially in semi-arid regions. More frequent and intense extreme events such as heat waves, droughts, floods, storms, and tropical cyclones are projected to increase with each additional 0.5 degrees Celsius of warming, likely to bring greater risk to natural systems. As species move or go extinct, there will be changes in species composition, structure, and function of ecosystems. At the same time, there are a few things we can do to minimize the impacts. Reduce non-climatic stresses to increase resilience of ecosystems, for example, reduce water extraction from rivers. Expand and manage effectively the network of protected areas, including terrestrial, freshwater, and marine areas, to safeguard biodiversity. Increase the size of habitat patches in fragmented landscapes, and increase connectivity of remnant patches. Monitor ecosystem responses to changes in mean conditions and extreme events. manage ecosystems to build ecosystem functions and services rather than attempting to current species composition. Assisted translocation and migration of species. A climate-ready vegetation guide for natural resource managers is available at the Australian Network for Plant Conservation. And that is my talk. Thank you.
It's good to see it didn't freeze. Thanks, John.
I mumbled one word, but I think we'll just let it go.